Okay, first question. What is the value of delta H? I want you to write it in your notes. What is the value of delta H? And remember, Veronica, when I say value, what does that mean? I'll rephrase it in something that you might understand better. If I said, what is the value of your age? What would you tell me?
There are? Like
What?
how-
What would you say?
My age?
Yeah. What is it?
17.
17. 17 is a number, right? That's what value means. So value means give me a number. All right? Just use that. It's a little bizarre example, but value means number. So what is the value of delta H according to table I, the nautical? What is it?
3351
3351 what?
KJ.
KJ. Good.
So the negative is
Is
not
it
a-
negative? That's what I was going to ask. Is it
It's
negative?
negative.
Yeah. Okay. Make sure we put that in there. Good. Anybody confused about that? We're good? Okay. Next question. Silas, is this endo or exotherm? Exo. Good. How do you know? Because it's negative. Corey, what does that mean? Say it differently. Energy's not really being taken away. Yeah, the energy is being given away, or it's being released. Energy is being released. Now, to you, it may not make a difference, but I just want you guys to think of the energy is being released or given away. The way he said it was fine for him, but I like to say it a different way. Yeah.
Would it be okay if we said it like the energy is transferred?
No.
Okay.
Well, you can actually, yes, but you have to add something to that. You have to say the energy is being transferred
From the thing.
from the reaction to
Yeah.
the surroundings,
Yeah.
environment, or whatever. Does that make
Okay.
sense?
Yeah.
Okay. All right. So energy is being released. It's negative. It's exothermic. Good. All right. Next question. I want you to write this down. I'm gonna come check it. What is the mole ratio? What is the mole ratio between aluminum and oxygen? This could be a valid Regents question. They'd give you this reaction, so they'd say, given the following reaction, and then they'd print that. Underneath this, the question would say, what is the mole ratio between aluminum and oxygen? And then it would give you 4 choices. And when I say ratio, what do you guys think?
Like 2 out of 2 to 1, 2 out of 1.
Like, yeah, 2:1 or 2/1, right? Something like that. Yeah, that's a ratio. So I don't care how you write it. Use a colon, use a division line, one over another, I don't care. What's the mole ratio between aluminum and oxygen? Which answer? I want aluminum and oxygen.
So do we have to take it from both sides?
So you got that.
I don't know what that's what she said. What do you mean? What does that mean?
Like the AL from there and the AL from there.
Well, the second equation.
Okay, hold on. Let me. I see the confusion. What's this called? Aluminum. What's this called?
Oxygen.
What's this called?
Aluminum oxide.
Aluminum oxide.
That's a completely different thing.
I'm not talking about this.
Oh, you're
Yeah,
right.
that's the product.
No, that's the product. That's called aluminum oxide. That's a compound. I just want to know what's the mole ratio between aluminum and oxygen.
Okay, then my first answer.
Yeah, I see the confusion there. Yeah. The more we learn about this, and when we get into bonding, that'll be obvious to everybody. I can see why you're getting confused, so I apologize there. But so yeah, just the reactants. What is the mole ratio between aluminum and oxygen? And let's see what we got here. All right, we did pretty well. How many moles of aluminum? What's happening? Jake, what are you doing over there?
As you're looking.
Stop playing with his back. How many moles of aluminum do we have? 4. So the whole point of me going over the first couple saying the number in front is the moles, so you can answer this question. So if you made a mistake, it's all right. Let's just learn from it. So there's 4 moles of aluminum. Do we all agree?
Yeah.
There's 3 moles of oxygen. Do we all agree? So the mole ratio is 4 to 3. Or 4 over 3. Now Jake, for example, I don't think he minds. He didn't round, but he said it's 2 to 1.5. So it must have been another Jake.
Right
So
there,
and that's fine because he's not wrong. He's not wrong. A 2 to 1.5 is the same as 4 to 3.
Oh, then yeah.
Okay. So, but on a Regents, they probably won't reduce it. The only time they reduce is if the number, if all of them can be reduced. In other words, if this was a 4 and that was a 6 and that was an 8, then you could reduce it to 4, 3, 2. But anyways, the mole ratio is 4 to 3 because there's a 4 here and a 3 here. Questions? Okay, let's try another one. What is the mole ratio between oxygen and aluminum oxide? What is the mole ratio between oxygen and aluminum oxide?
Good afternoon. The final group that needs to have their picture taken today for the yearbook is the class of 2019. So our present seniors, class of 2019.
Hi, Corey.
Everyone from the class of 2019 report to the auditorium. Thank you.
Have fun, Corey.
Okay, what is the mole ratio between oxygen and aluminum oxide? I'm not going to come around, let's just go over it together. Who knows?
3-2.
3 to 2. It's a 3 to 2 ratio. Questions? Ask me now, because I'm not going to go over this again.
Going once. Going twice. Sold.
Alright, so that was supposed to be the easy part of the day here. Now the more challenging question. Alright, we're going to use the exact same reaction, write this question down. What is the value of delta H? What is the value of delta H RXN if 2 moles of Al solid react? This is the last new thing in this unit. Last new thing that would be on that test. We're going to do 2 or 3 practice problems, and then the homework is more of the same. So go ahead, write it down. What is the value of delta H if 2 moles of Al react? Now, I don't want anybody saying anything. Just think. I'm going to explain a little bit, give you some hints, then I'm going to have you pair up, try and figure this out. Then we'll go over it.
Should we have a calculator out?
Yeah, that was my next thing I was going to say. You need a calculator. I really don't want you to use your phone, so come up and grab one if you don't have one. Not sticking, is it?
Hmm.
Alright, so here's my hints to you guys. You like to cook or bake?
Oh,
Both. Which one do you like better?
bacon.
Alright, what do you want to bake? We're gonna theoretically you can bake anything right here, right now. What would it be?
What?
Cookies. Alright, what kind?
Well, I have my recipe down pat. You want like the actual ratios?
Yeah, sure, but what are we making?
Oh, chocolate chip.
Chocolate chip cookies. My daughter loves those. They're the reason I'm talking about this, by the way. Alright, so what do you start with?
You put it in the butter. We soften it. Soft butter.
Soft butter.
Butter,
Soft.
sugar, and then 1 egg,
1 egg.
a stick of butter,
Stick of butter.
1 part granulated sugar, 1 part brown sugar,
Okay.
and then like a tablespoon of vanilla. And
Okay.
then mix that all together.
Yep.
And then it's 3 parts flour, and then tablespoon of baking soda, and quarter of teaspoon of salt.
Almost some of those.
Nice.
And then-
Alright.
and then-
Alright, okay.
Not really lost. Cookies are
But of course you double the other stuff if you're doubling the recipe. That's just the other stuff. But
I feel like I'm watching Paula
the ratio
do
of the
this.
sugar and the flour is 1 to 1.
Very good.
Okay, alright. So, wait, this is great. So, I think maybe she's picking it up. Why am I talking about baking right now?
Ratios.
Ratios. So, how many cookies does all that make
About
typically?
4 dozen.
About 4 dozen cookies. Alright.
Wow.
You are serious. You sound like you're good.
Yeah, I usually double it.
This
though.
is such a
Bake a lot.
premeditated pot.
It's good.
Oh,
Well,
yeah.
she does
I
it,
got
so she has memories.
Double ovens. I can get.
Oh, really?
I can get 8 dozen done in like an hour and a half.
Dang.
Wow. Alright, okay. Alright, maybe you got that in your future. Alright, now, like as a profession. If she wants to make how many? 4 dozen?
4 dozen.
Alright, so she just rattled off all the ingredients. You didn't have to pick up all that. But if she wanted to double that and make 8 dozen, what would you have to do with all the ingredients?
Double.
You would have to double them. Everybody knows that, right?
Yeah.
If you want to make more, whatever, cookies, cake, pancakes, whatever, think of other foods, all right? Lasagna, right? If you want to make lasagna for like 6 people, that's different than if you want to make it for 60 people. You're going to need way more pasta and sauce and whatever.
I mean, if you want to make it quick, you gotta turn up the heat.
Right.
Gotcha.
Not really. So now, everyone following my logic here, hopefully, how does this relate to this? Here's how it relates to this. So this reaction has a delta H, all right? And we know that the delta H should be over here, 3351 kilojoules. So everyone stay with me, focus.
I am.
If I take 4 moles of aluminum, so again, this relates to the baking of the cookies. The original recipe, we have 4 moles of this, 3 moles of that. Well, 3 moles of this and 4 moles of that react. How many moles of product do I get? 2. It's 2 right there.
Okay.
Okay? So 4 moles of aluminum reacts with 3 moles of oxygen. Again, think of like your egg, your flour, whatever. When you add a certain amount of them together, you get 4 dozen cookies according to her recipe. Well, that's what this recipe produces, 2 moles of Al2O3. So 3 of this, 4 of that equals 2 of this. Everybody with me? Also, in chemistry, it's not just products, but heat. Heat's either given off or absorbed. In this case, it's given off. So what this question is saying or asking is if 4 moles reacts with 3 moles of this and produces 2 moles of this, it also produces 3,351 kilojoules. So if 4 moles produces this much, well now the question says, well let's change the recipe. We're going to cut this in half. And yes, of course, you have to cut this in half and that in half, because that's the way cooking works and baking works. You couldn't just change one ingredient, right? You have to change them all. Right. So if we cut this in half, the question doesn't care about this, even though it would change. It doesn't care about this, even though it would change. It's just asking about the delta H. So it's just like a recipe. If you change one, all the others have to change, but on the reagents, they're only going to ask about 2 parts. They're asking about this, and they're asking about this. So, pair up, figure out what the answer is. And I need a number.
Well, you just divide.
1, 6, 7, 5, 50.
Are you two going to converse? Or you already did? Okay.
Is that first number a 3?
3351. 3351.
5351.
3351. Yeah, it's a little messy. What else is new? You
Good
two
guy, yeah.
converse?
Yeah,
Did you two?
Yeah.
Yeah.
Did you two? You two? You two and you two? Everyone's done? What's the answer?
1, 6, 7, 5.5. I don't know.
Okay.
You nodded.
What did you two do?
If you're cutting in half one ingredient,
Yep.
will you cut the other one in half?
Absolutely.
So,
You're
what-
finding kilojoules.
oh, I thought we were just.
You were doing this one to 1.5.
Yeah.
Okay. You would be right. What happens to the heat?
Oh, that would also cut in half.
Yes.
Oh, okay.
That's the answer. So here's how so it's, what is it, 1675.5?
Thank you.
Yes.
Yeah. So here's how we show work, and I want you to write it in our notes. If 4 moles of aluminum produce 3351, then 2 moles produces X. I'm a big fan of proportions. If you're not, that's unfortunate, because that's how I teach. So 4 moles of aluminum produce this much, so that's 4. 4 is to 3351, so the way to say it. That's a ratio. Just like 2 is to X. Again, the reason I talked to Kaylin about making cookies is it's literally the same thing. If you're cutting one in half, then your products, whatever's on this side, will be cut in half as well, as long as you cut all the other ingredients in half. So that should make sense to anybody who's cooked or baked, or you just understand the concept, hopefully. It's the same thing in chemistry. There's a fancy word for this, it's called stoichiometry. That's what this is called, stoichiometry. Yeah, it's a very bizarre word. So, this math is a little more complicated than just dividing in half, I get that, but you're gonna have to show work on the reagents. You can't just get an answer unless it's multiple choice. Anyways, The answer is negative 1675.5 kilojoules. So does it make sense to everybody? If you cut one in half, you cut the other in half?
Yeah.
I'm trying to spell it out very clearly for you. Okay, let's do one more practice here, and then I'll talk about the homework, make sure you know what to do.
And
That's
marble.
gonna be right, and then I'll show you the marble. Okay, let's do one more. I'm gonna write a reaction down with a question. You guys write it down, answer it. And I'll take the marble out.
I better not be just.
Yeah, I was gonna say, you're probably, this isn't like super great.
I've been waiting for this for a while.
But it is cool. Write this down, please. Get this down, get this down. Alright, so there's your reaction. On a Regents, they may just give you this and then ask a question. They're not going to tell you to look in table I. They're not going to give you any help. They're just going to give you the reaction. They're going to say, given the reaction, and then here's the question. What is the value of delta H, heat of reaction, delta H RXN, if 4 moles of H2 gas react? Alright? And if you're picking this stuff up pretty quick, that's good. But make sure you show some kind of work. You gotta show some work for how you get your answer. Alright? So I want a number. We'll go over this and then explain the homework. You have a question or you know the answer?
No, I'm just asking what the RX stands for.
Reaction. No lab today. I'm sad.
Good.
That's what everybody keeps saying. That's right. So Denautica and Silas, I'm just gonna delete your emails. We're good, right?
Yeah.
Yeah. Did you get my selfie?
I saw you and your sister's selfie on the iPad back there when I was trying to set it up for.
I sent
Well,
it
that
to
was when we
that
were
to
looking
print
for
it,
our
but
graph.
Mr.
Yeah,
Becker
that
said there
was
wasn't
on
enough.
Oh, that was the other image. I didn't click on that.
Yeah, there wasn't enough ink.
Too bad. I'm gonna sound like I'm getting old here, but if you were to rewind like 20 years ago, I realize you guys weren't alive yet, but rewind 20 years ago and someone told me a big thing with people in 20 years is they're gonna be taking pictures of themselves on phones, I would have been like, what planet are you from? Like, it's hard to explain and understand because you're the age you are, but that's like wild concept when I was your age. That's life. Things change. Not sure why some people take so many pictures of themselves.
The H.
Does everybody do it?
No.
Oh, I
Like,
did
does
wrong one.
every single person take selfies?
Well, occasionally.
I mean, I take selfies with my daughter. Is that
Yes.
weird?
Maybe
friends.
with, yes.
Like with my daughter.
I'm not gonna
Whatever.
sit down by myself and take a selfie.
But that's
I
what
might take it
technically a
with some
selfie
people.
is, right? I
I'm the
mean,
first 17-year-old of all time.
you know who I blame for this? Kim Kardashian. That's who I blame. She's what's wrong with society. This is being recorded. You can publish that.
That's hilarious.
We can quote you on this
Her
now.
and her family. I'll stop. I'll get off my soapbox now. All right, what's the answer?
4, 5.
Hold on, he's working feverishly here.
Yeah, because
I
I
don't.
should go to my answer.
Alright, I screwed up. I don't know what I'm doing.
Okay, here we go. Here's how we do it, and then I'll show you the marble. All right, now,
No. I have it right here.
what's the Tyler? Tell me the value of delta H on table I.
52.4.
Yeah, 52.4. Good. So the 52.4 go over here.
No. Oh, yeah.
Right, it's positive.
I did the wrong one.
Okay.
Oh,
It's positive. All right. Okay. So now, eyes up here. 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 Speaking of selfies, Okay, now, 2 is to 52.4 equals, now we're changing the 2 to a 4. That's what this question is saying. So we're doubling the hydrogen. What happens to the delta H? So if we double the hydrogen, we would double the delta H. So cross multiply, divide, all that fun stuff, and it is 104.8 kilojoules.
Yeah.
Okay, now just take your homework out. You can pack up and take your put your notes away, but take your homework out. I want to make sure you know what's going on, and then I'll show you the market.
Okay.